Hey everyone, Mr. Aarons again. Today we're going to be continuing working on what we did a little bit earlier this week, and you had some practice with yesterday. We're going to carry on with that, add a little bit to it. It'll be a little bit different, but I think a lot of it will make sense in similar ways. A couple key differences today. So lesson 2.9 was on solving one-step inequalities by adding and subtracting. We also last week did solving one-step equations by adding and subtracting, and solving one-step equations by multiplying and dividing. Today, we're putting it all together again, solving one-step inequalities by multiplying or dividing. Naturally, there's a couple key things about this lesson that are unlike the past lessons that we've done. So I'll make sure to tell you when those important things come up. Make sure you get those in your notes. The first thing right here, this whole first page that I have up here, this is all important right here. This whole block, everything that you can see here is super important. I know it's a lot of writing, but if you're really, really trying to do the most with your notes for your testing quizzes, this is all great stuff to put in your notes. So if you want to pause right here, start jotting this down, you're more than welcome to, and then you can have full attention as I talk about it. That's what I recommend. So I'd say pause right here, write this down, and then you can listen as I talk about it. All right, here we go. So, division property of inequality, similar to what we talked about last week, but there's a key difference. The difference is if we divide by a positive number or a negative number. Those are two different circumstances. We'll talk about them both right now. So to start, when dividing by a positive number. So we know if you divide by a positive number and you do it to both sides, you're allowed to do that. Just like how we did last week, just like how we did yesterday or 2 days ago with addition and subtraction. As long as you do the same thing to one side as you do to the other, whatever you do to one side, you have to do to the other. As long as you follow those rules, that's always okay. So when a positive, if we do 3 is, do my L, less than 6, so 3 divided by 3 is less than 6 divided by 3. We divide them both by 3. Whatever we do to one side, we did to the other. Checks out. 8 is greater than 2, so 8 divided by 2 is greater than 2 divided by 2. We divide each side by 2. Whatever we do to one side, we have to do to the other. Here's our key thing for today. There's a difference when we divide by a positive and a negative. When we divide by a positive, you do it just like you would expect, just like regular. You don't flip anything. You divide each side. As long as you do one side, you do the other, it'll work out. Have a little key for you over here. If you follow that, you'll all be good. So if we're dividing by a positive number, do it just like you'd expect, just like we had last week. Here's our key for today. This is the big detail for today. I'm going to pull out my green marker so I can highlight a little bit here. This is the big key for today. I'm going to draw a little key here. When dividing by a negative number, if you divide by a negative, the symbol reverses. This is huge. This is huge, 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 huge. So if we do 6 is less than 12, and we divide by 6, 6 divided by negative 3, 12 divided by negative 3, we divided by a negative. We divided by a negative number. Look how that symbol flips. Instead of 6 is less than 12, it becomes 6 divided by negative 3 is greater than 12 divided by negative 3. Why does this happen? This happens because when we divide by a negative, we know if we divide a positive by a negative, the number will become a negative. So this becomes a larger number than this because this will go farther into the negatives. Right now, this would be further in the positives. 12 is bigger than 6. It's further in the positives. But when we divide by that negative, it will go further into the negatives. It's going to be a bigger negative number. This is going to be a smaller negative number, which in our timeline, on our number line, it may say greater. So our key is, if you divide by a negative, the symbol reverses. We'll get some practice with this right now. Get all this in your notes. Great stuff to have in your notes. Put these examples in your notes as well. Looking at this first one, we have 4x is, nope, that's not an L, greater than 40. 4x is greater than 40. We're doing the same things that we did the other day. Variable alone, that's our goal. Let's get the variable alone. I'm just going to do whatever we do to one side, we have to do to the other. I know it's the longest little abbreviation thing. It doesn't make any sense, but I want to write it all out. Whatever we do to one side, we have to do to the other. So how am I going to get this x by itself? Right now it's 4 times x, the IO, aka inverse operation. To get x by itself here, right now it's 4 times x. We know the opposite of multiply is divide. Divide by 4. Whatever we do to one side, we have to do to the other. Now we go back up and look at our rules. We divided by a positive number. If we divide by a positive number, if you divide by a positive number, the symbol does not change. Perfect. We can do this just like we regularly would. This becomes, these cancel out, leaving us with x is greater than 40 divided by 4. I know that is 10. We did that one just like regular, just like what you know. No confusion, no problem. The next one, negative 21 is greater than 3m. How do we get that m by itself? Our goal is to get the variable alone. We're going to divide by 3 here. We know it's 3 times m. To get that by itself, we're going to divide by 3. That's our inverse operation. Whatever we do to one side, we have to do to the other. These cancel out. Perfect. Okay, this is where things can get confusing. Don't let this confuse you. We're talking about the number that we divided by, not the number that was already there, the number we divided by. So, did we divide by a positive or a negative? 3 is a positive, so we follow our positive rules. If you divide by a positive, the number does not change. C, in this case, was a positive 3. The symbol does not change here. So we leave it same way. Symbol doesn't reverse. Negative 21 divided by 3. Some of you can probably do that in your heads. I'll give that one to you. I know that 3 times negative 7 would be negative 21. Negative 7 is greater than m. All right, it's the moment of truth, the moment you've all been waiting for. Our chance to practice what we're learning. Here we go. We got 36 is greater than, that's not an L, goes the opposite way, greater than negative 9 times t. I'm trying to get t by itself. Right now it's negative 9 times t. To do the opposite of that, the inverse operation, we're going to do divided by negative 9. Whatever we do to one side, we have to do to the other, just like we've been doing the last 2 weeks. These cancel out. Uh-oh, here it is. Did we divide by a negative or a positive? We divided by negative 9. If you divide by a negative, the symbol reverses. Uh-oh, here we go. We've got 36 divided by negative 9. I know that 9 times 4 is 36. So I know that 36 divided by negative 9 is going to be a negative number, negative 4. On this side, we have t. We cancel out those negative 9s. We said it. If you divide by a negative number, the symbol reverses. Here we go. Look at that. We're changing that greater than into a less than. That's our final answer right there. We flipped that. We divided by a negative number. We flipped that. If you need an example in your notes, this is the example to have right here. This is it. This is our key example. We divided by a negative. We flipped the symbol. Notice how that symbol flipped. Okay. An elevator carries 2,500 pounds. How many people, or how many 150-pound people could ride at once? X is the number of adults. We're going to set up our problem here. We know that we could do, to get 2,500, we're going to do 150-pound people, and we're going to figure out how many of them we can do. Rewrite this as 150x is less than or equal to 2,500. Divide each side by 150. We're dividing by a positive number right now. When we divide by a positive number, we do not have to change our symbol. Only when we divide by a negative number. You'll get practice with that on the homework. This isn't going to be an exact number here, but it should be roughly, let's see, I'll punch it in here. 16 and 2/3. So that would be 16 people. Big takeaway from those problems so far. If you divide by a negative, the symbol reverses. We divided by a negative down here, we reverse that symbol. We did some practice with that today. Backside, multiplication, same ideas, same thing. We're going to crush this. If you multiply by a positive, the symbol does not change. Easy peasy, just like we regularly would. If you multiply by a negative, that's when our symbol reverses. Same for multiplying. Our symbol reverses. So right here we have 6 is less than 9. So 6 times negative 2 is greater than 9 times negative 2. We reversed that symbol because we multiplied by a negative number. Good stuff to have in your notes right here. If you want to pause, you get all this down. Awesome things to have in your notes. Moving forward, let's get some examples going here. 2 divided by, or 2t divided by negative 4 is greater than or equal to 7. We're thinking about the inverse operation. How can we get this t by itself? The opposite of divide by negative 4 would be times by negative 4. Whatever we do to one side, we have to do to the other. Times negative 4 over here. We multiplied by a negative. Whenever we do that, we know our symbol reverses, so I'm going to change it right now. I flop that symbol. These are going to cancel out, leaving us with t on this side. Over here, we've got 7 times negative 4. I know that's going to be a negative number. Think about that in my head for a little bit here. And I know that should be negative 28. We flipped that symbol. Notice that symbol, it flipped because we multiplied by a negative number. On to the next. M divided by 4 is greater than 2. How can we get m by itself? Well, we can multiply each side by 4. That'll cancel these out. Whatever you do to one side, have to do to the other. Leaves us with m is greater than 8. We didn't have to flip the symbol there because we did not multiply by a negative number. We multiplied by a positive. The symbol does not change. That's our big key right here. I got one more for you here, and then we're going to do some bonus questions. Actually, you know what? I'm going to make this a negative number right now. I want to get some practice with it. R divided by negative 7 is, I'm going to restart. 5 is less than, we got that L, less than R divided by negative 7. How can we get R by itself? We can multiply, do our inverse operation, which would be multiply by negative 7. Whatever you do to one side, have to do to the other. These cancel out. We multiplied by a negative. That means what? Our symbol reverses. I'll flip that symbol right now. 5 times 7 is 35. I know it's a negative 7, so it has to be negative 35 is greater than R. Oops, sorry. Okay, I've got one more example for you. Sorry, my video is a little long today, but I think this is a huge lesson. And here I have a bonus track. There's a way to avoid this all. I don't suggest it always. I think if you can master this, this is the best way to do it. But there is a way. I'm going to show you the no-flip method real quick here. What we can do is we can do this like an addition or subtraction problem. What I'm going to do here, I have negative 3x is greater than 12, or less than 12, my bad. I got the L there. Less than 12, what I can do, instead of dividing this by negative 3, to get x by itself, I can add 3x to each side. Plus 3x there, plus 3x there. These will cancel out, leaving us with 0 on this side. 0 is greater than 12 plus 3x. We still have to get that variable by itself. What can we do? Subtract 12 here. Subtract 12 gets us to negative 12. And now we are dividing by a positive number. Look at that. We're dividing by a positive number now. We don't have to do any flipping. Negative 12 divided by 3 is going to be negative 4. If you move this over to this side and change that to 0, we can avoid any symbol flipping. I think this is the easiest, quickest way to do this method. I suggest it. But if you want to get some work in with this, you're more than welcome to. So I'm going to show one more quick example. Instead of dividing by negative 6 here, I'm going to add 6x. Add 6x to each side. It's 18 plus 6x. And on this side becomes a 0. Minus 18 from each side. Whatever you do to one side, have to do to the other. And finally, divide by 6 to get x by itself. I know that was quick. This isn't the method I want you to focus on the most, but if it works for you and you like that, you're more than welcome to do it. I want you to do what works best for you. Get those notes down. Key takeaways. Big takeaway from today's lesson. If you multiply by a negative number or divide by a negative number in our inequalities, if you multiply or divide by a negative number, the symbol reverses. That's my big takeaway for today. You'll get plenty of practice with this the next 2 days. Key things to remember. Make sure you get this in your notes. Let's crush this.